Welcome and thank you everyone for joining DoubleRadius for today's webinar entitled Growing Your ISP with Ubiquiti, Fusing Fiber and Wireless. We're pleased to be presenting this webinar in partnership with FISPA. We would like to extend a special welcome to any of our fellow FISPA members that are in attendance today. At last month's FISPA Live conference, we engaged in discussion of hybrid networking, which includes the use of both fiber and wireless. And today's presentation is a continuation of that theme. Joining us today, we have a large and diverse crowd of ISPs, integrators, MSOs, and various other types of networking professionals. Whatever your background, we believe the hybrid discussion is important, and we hope that today will inform your upcoming network decisions. We have two speakers today that I'd like to welcome at this time. First, Jeff Holderman is our VP of Sales and Engineering here at DoubleRadius. Jeff has been helping design networks for ISPs and others over the last 17 years, and we're looking forward to hearing from him today. Our other slated speaker from Ubiquiti was unfortunately able to make it, but we're glad to welcome Ubiquiti certified trainer Caleb Nauer for stepping in. Caleb teaches Ubiquiti admin training classes here in Charlotte and is our technical services director. Throughout the webinar, if you have any other questions on the material, please enter them into the questions box, and this will allow us to answer them during the Q&A portion at the end of the webinar. Lastly, at the very end of the webinar, please take just a brief moment to complete the survey that will appear on your screen. And with that, I'll turn it over now to Caleb to get us started.
All right, everybody. Like Chad said, my name is Caleb Nauer. Not sure I was introduced second. A little bit hurt about that, but you know what? It's okay. We'll learn to deal with it. So what I'm here to talk about is the Ubiquiti G-PON fiber offering that is now available. Now, the UFiber family of products is not new. It's been around for a little bit, but recently there's been a lot of product maturation, some new additions, some products with the OLT4, the Nano ONU. So a lot of really cool stuff has come out on the platform. The UNMS integrations really added a lot of features and everything lately. So we think this is a really great opportunity to talk to you guys, especially this diverse background that we've got, about the offerings that Ubiquiti has. Now, for those of you in the fiber world, you're already familiar with G-PON, and that's great. We're going to get to your bit in here in a little bit. But for those that are not familiar, I want to talk about it for just a second. I'm going to try not to slide read as much as possible. So G-PON stands for Gigabit Passive Optical Network. Now, passive here being the key word. Anyone who's done any sort of networking, used an SFP on both sides of a link or both sides of a fiber to connect a couple of switches, that's referred to as active fiber networks. You can build outdoor, robust, active fiber wireless, active fiber networks that works fine. There's some pluses and minuses, and we're not going to really get too deep into that comparing the active side, but what we're going to focus on is the passive component of a GPON system, the cost savings in the those things that it's offering you. So as you know, the purpose of GPON is to carry Ethernet packets across a long distance and not really having to deal with noise. In a wireless world, we're constantly dealing with all sorts of issues, getting a link from point A to point B, whether it be line of sight issues, foliage issues, height issues, but more and more increasingly, we're having the issues of dealing with noise and interference. Great thing about fiber networks is we all know you get the stuff in the ground, you get it hung up in the air. Once you get that part, the tough part of it done, you're not having to worry about noise. You can offer dedicated bandwidth. You can go short distance, long distance. You got a lot of potential options. Now, as I said, it uses a passive optical network. Typically, we're using single mode fiber to connect all these points together. And again, we're going to point out here is without the need of an active distribution point. And this is really in a GPON network, this is where your cost savings comes from. Because when you want to branch out your fiber runs, you want to split and parse out the different areas, you're not having to run active gear, which means you're not having to run active cabinets with powers and heat and AC control. You're not having to deal with, of course, the power issues in general. It's a lot easier to maintain. It's a lot easier to manage. You have a lower cost point to get these things done. You can apply it to a lot of different scenarios. We see a mix. Traditionally, GPON networks have come from, first got really popular doing mass deployment sort of stuff and MTUs, NDUs. You see it a lot in the corporate world because the cost price point has dropped down to the point where you can effectively deploy there. But we're also seeing more and more use building out to neighborhood networks and larger sort of scope networks. Now, again, those of you in the active camp, you've got plenty of reasons to use active. Those of you already doing GPON, you feel very strongly about it as well. And honestly, it turns into a big Ford Chevy conversation. And we're really not going to get too much into that religious dogma debate here, but we're focusing on the G-PON and especially the Ubiquiti's version of it, which has recently come out. So why do we want to use Ubiquiti Fiber, UFiber G-PON networks? Okay, so as we all well know, Ubiquiti's big push is they want to come into a market, they want to be disruptive. And with this market, as well as everyone else that they've got into, they were able to provide that disruptive factor. So, and it's not just, based primarily on pricing. Yeah, it's a big part of it, right? But, there's so many options out there for low-cost fiber networks, you can't get everything down to a nickel and cent approach. Some of the things that are really going in UFiber's favor, especially those that are already using wireless networks and want to get into doing fiber deployments, they're familiar with sort of the background, the community. So you got the user experience. You're familiar with the stuff. You're probably already using UNMS to control your wireless networks. You're familiar with how they operate, firmware updates, and all these other things. Community support, big option. But, one of the most enticing parts of all of this is the, relatively low barrier to entry to get started in doing these types of networks. Now, I'm not going to sit up here and say, doing fiber is a cheap way to lay a bunch of bandwidth out, right? You've got to get the stuff in the ground. You've got to get the labor. You've got to get the tools and everything else. However, when compared to doing other competitive market G-PON networks, the barrier to entry is very, very low. You can very easily and very inexpensively get your OLTs, get some ONUs, play around with some options, have a running lab demo network very, very quickly. Learn the in the outs, learn how to use the platform. It is so much easier to be able to jump on that type of platform and pick it up versus one of the sort of mainline carriers. So that means you can test, that means you can learn and say, hey, is this something I really want to do? So when we talk about the UFiber G-PON components, there's two main parts of it, okay? From Ubiquiti, there's the OLT, optical line terminal. Now, as part of a G-PON network, this is a fairly standard piece of kit in terms of a design perspective. However, this is the heart of the G-PON network, and it operates similar to many OLTs. Now, each PON port here on this OLT can serve up to 128 separate ONTs. These ONTs are communicating all encrypted communication, and it's using a TDMA timing protocol for timing and traffic control in your upstream. And again, these are all part of the G-PON standards, and this is, is type of deal. Where Ubiquiti products really set themselves apart, though, are with the product offerings and the cost point. So if you look at their two OLTs, you have the original one, the first unit that came out, UFLLT. This has got 8 PON ports, 2 SFP Plus ports. This is coming out at a price point that is extremely competitive in the market. Not too long after, here just recently, they released the OLT4. This is like its baby brother, okay? It's got 4 PON ports, 1 SFP Plus port. So if you look at the price points and what we can offer you, these products at a pricing point, you're going to see very quickly there's a very low-cost alternative and see that you can easily get these things up and going. Now, when we're talking about G-PON networks, again, because it is relying on a standard, you have the standard sort of speeds and performance metrics, right? So each port, each PON port is capable of doing 2.5 gigs down by 1.25 gigs up. Range-wise, it all depends on how many times you split that fiber up. If you're doing a direct one-to-one, from a long distance run between a PON port and then the ONU, you can go up to 20 kilometers. Now, you start busting that out to a bigger spread of splitting, splitting up, 1 to 128, at the extreme, 164, 132, however you want to split that up, that is going to cut your distance down a bit, okay? In the extreme case, 1 to 128, so you take out PON port and split it out to 128 clients, that's going to knock your max range down to about 8 kilometers. So, but the price point here, like I said, very important, easy to manage. We'll get into that a little bit more. Now, we start talking about the ONUs. These are your optical network units. Those from your wireless world, your OLT is like your access point, your ONU is like your CPE device. This is your customer premise equipment. And typically, this is a demarc between your network and the customer's network, whether it be a residential, whether it be a business, whether you're in an MDU and running to each one of the individual apartments, however you're splitting it up, that is typically the demarc between the two networks. Now, you can push that further back if you like. We'll talk about that in a second. Primarily, the purpose of the ONU is to act as your fiber to Ethernet conversion. Convert the light to electrical copper. You can place these in a lot of different areas, you know, depending on where you are. Primarily in the US, when you're doing residential, these are typically in an outdoor enclosure on the outside of the house, and then you're coming out of there with Ethernet, pushing it into the residence or whatever building you're going into. Mainly because it makes for a cleaner demarc, mainly because it makes access easier, and a lot of it's just a lot easier to pull Cat5 cabling through the house rather than trying to fish a fiber up through there. So makes for a very clean point. Now, other parts of the world run things a lot differently, and that's great. You know, everyone's kind of got their own way of doing things. We look at the two main offerings for the ONUs. You have the UFiber Nano and UFiber Loco. Functionality is very similar. They're both powered by PoE from the inside. You can bridge them or you can route them. Manage them all with UNMS, of course. Main differences being the Nano has an active display, which is really handy. So it'll tell you what the current throughput is. It'll tell you the IP address, and it'll actually function as a signal meter. So you can see what your light power is coming from across your network directly into the unit itself, which is a real handy sort of check. Hey, I've got enough light here. It's going to be able to run. The Loco, again, similar functionality, but it does not have a display. The trade-off there is it doesn't have a display, but it comes in at a significantly lower price point. So which one you use, you know, really depends on how you want to manage the network and how you want to be able to give these offerings and the display things and so on and so forth. Now, we talk about the topology of a UFiber G-PON network. In its most simplest sense, we've got the picture here, okay? So you can see here, we've got an OLT fed by some nebulous internet cloud, you know, whether it be the rest of your internal network, whether it be a router that plugs directly into that, whatever. The device doesn't care. As long as you pump some Ethernet in, it's going to be able to spread Ethernet out throughout the G-PON network. So the OLT from each one of those PON ports feeds down, goes some distance of fiber down the road, down the apartment, down the building, whatever you're doing, it hits a passive splitter. Once it hits that splitter, then you can break it up however you want, 1 to 2, 1 to 4, 1 to blah, 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 all the way up to 1 to 128. You can take sublinks down there and bust those out as well. So in this example, you know, again, this is a very sort of generic topology layout. But you can see here, this is like be an MDU deployment, and they're putting them in every single unit throughout the way. So that is an enclosed sort of ecosystem, and like I said, as long as you're putting Ethernet in, you can spread this out. Ethernet is going to come out the other side. Now, if you look at the big picture from Ubiquiti and how their GPON offerings tie into the rest of the network, you can see it fits in really well. So you can see in this example down at the bottom, you've got the OLT, and it's feeding into an aggregation switch, the edge switch 16XG. These might be feeding other switches, uplink, uplink, uplink. Eventually, you're going to hit a router at some point. Once you hit the router, in this example, the 8XG, ton of capacity, ton of potential throughput, really powerful device itself. From there, it dumps out into the quote-unquote internet. Or maybe it dumps out into the rest of your network, and you're routing between various sites, nodes, hubs, however you want to split it up. If you look at your deployment scenario then, so you go, you know, internet or the rest of the network through your router, through your aggregation switches, through the OLT, down the glass, through the splitter, to the ONUs. Then you're like, well, what do I do with it from here? So you could just dump an Ethernet port to a customer and let them handle it. You could put in an air cube. You could put in an amplify, run your Wi-Fi networks for internal usage there, do all your routing and stuff in those devices. You know, if you got an office deployment or something, maybe you dump it into a little edge router X or, you know, one of the other edge routers, and you go unify and connect everything through there. So again, the GPON offerings that they do can fit into this network topology really well, but it also fit into pretty much any other. Like I said, it's Ethernet in, Ethernet out. So whether you're Cisco shop, whether you're pure wireless shop, microcable, whatever you may be using, this will integrate into that beautifully as well. Of course, with Ubiquiti, if you're using this whole platform, you are able to manage all of this with UNMS, which makes it really handy to be able to monitor and maintain your entire network. There are some design considerations. You know, I don't want to oversell how easy this is to do, of course, because there are a lot of considerations you have to take into account. But these are going to apply to pretty much any sort of GPON network, especially, but fiber network in general, right? When you're doing your calculations, you know, the one thing that you do have to consider when you're doing a passive versus active network is you've got to take into account what your losses are from the OLT to the ONU. So when you do that, you've got to look at your fiber length, you've got to look at how many splices you have, because that adds attenuation, how many connectors you've got. Obviously, the splitters are a big part of that. The more you split it, the more you spread that signal out, so on and so forth. So you got a lot of hot power coming out, but then you start spreading it, whether it be distance, whether it be through splitters, so on and so forth. Now, don't freak out. This is easy to calculate. These are all fixed numbers. You can get it figured out pretty easily. We're going to show you where to find that information here. The other good thing to know is the receiver strength of the light at the ONU doesn't affect the throughput. It's binary operation. As long as it fits in the required range for it to work, not too hot, not too weak, but right there in that Goldilocks zone, which is a very wide range, it's going to work. Your throughput's going to be great. Throughput's going to be the same. Other consideration that you don't really quite do so much with active is you got to look at your capacity versus client quantity. Do I want to have fewer ONUs at the end and have more speed, or do I want to load it up heavily and spread that speed out? Just for a reference, because it's a 2.5 by 1.25 port on the PON, if you bust it out to a 1 to 128, it's going to give you 19 by 9 per sub, which is still a considerable amount of bandwidth available for your application. And, you know, if you, instead of going to 128, you go to 64, you're going to double that, roughly. So, good information to know. Also, the design considerations, you know, Ubiquiti's making the active stuff, the stuff that needs to be managed. Well, active is probably the wrong word there. We have the components that Ubiquiti's not making for active electronics. Let's put it this way. So there's a lot of these different parts when we talk about fiber type, strand count, deployment method. You're going to have to source your fiber. You're going to have to figure how many strands you need, how you're going to deploy. Are you going aerial? Or are you going buried? Are you going to conduit or not? What splitters you want to use, splice cases, ONU enclosures. Now, the good thing is there are a plethora of options available to you from a lot of different sources, through us, through other providers, lots and lots of options. And because this is using standard-based stuff, then you're not really pigeonholed in any particular accessory that I want. Now, once you start getting big into this, you're going to need some tools and test equipment that you obviously don't have yet. But the market has really driven the price points on this sort of stuff down. So 10 years ago, if I would have told you that a fusion splicer was affordable, you know, it would have been like, well, we're talking about 5-figure affordable, 6, but it's not anything crazy like that anymore. There's a ton of fusion splicers that are out there that are easy to access, really reliable stuff. You're going to need an OTDR so you can manage your cable lengths, measure that. You're going to need an optical power meter. Obviously, locating equipment. So if you're going underground, you can locate where your stuff is and everything. But again, this is applicable to all fiber networks, not just G-PON, and especially not just the UFiber implementation. You're going to have to also look for, you know, you're going to have to get tied into your location services, permits, all these other things. Obviously, call before you dig, all the safety things. What you don't want to do is sink it into an underground power line because you're digging around because you didn't take the precautions. So again, all these things still apply, but because you're able to get up and running so quickly with this UFiber application, you can spend your time doing the planning and legwork for this sort of stuff and not trying to figure out your gear. As I said, UNMS. UNMS is how you're managing all those platforms. The fiber stuff, the UFiber family was built around being managed by UNMS. It was one of the first things that were majorly implemented, very well supported now. You can manage these inbound, outbound. There's a lot of stuff that you can do with these configs, whether you want native VLANs for customer traffic, or you want to split everyone off to their own VLANs. There's a ton of options. You can learn about it. It's really easy to use. You can run it locally, spin up a VM, put it on a box, use the UASXAG. You know, a lot of different ways to run the software suite in-house, so you're able to manage your gear, look at it, look at the performance metrics, and all these other fun things. Now, we do have a number of resources available that Ubiquiti gives us to figure out some of these bits and pieces, okay? First, you got fiber.ui.com. So it'll give you a walkthrough the family, MSRP, general descriptions, and so on and so forth. You can click on the products from there. Really nice resource here. If you go to help.ubnt.com, instead of just typing in this whole crazy thing, if you just look on the general categories, you can go to UFiber. They have a really good getting started article. They have a planning your network article where you can sit here and all those attenuation factors that I said before about fiber length and splitters and all these other things. Breaks all that out for you, gives you some good examples, tells you how to get spun up, and then some design perspective. There's just a lot of really good information that's being held there. You go to community.ubnt.com. You can see they have their own forums for the UFiber product. There's also the story section. You can look on there, see some people that have had some successful deployments. We're seeing more and more of those starting to pop up. And these are people, hey, this is how we're using this stuff in the real world. And then next is unms.com. So they have their own domain for this, but you can go there, you can download a demo, you can look at what all this offers, check it out, see how powerful this application is. So, and I believe that's me. So that's just, again, introduction to the Ubiquiti UFiber G-PON thing. There's been some discussion. We're just trying to get this word out here more that the product has matured, and hopefully looking forward to everyone playing around and start building their networks with it. So Chad, back to you.
So I think that's when I jump in. Thank you, Caleb. I mean, I've been doing wireless for a long time. This is Jeff Holdner at DoubleRadius. I've not studied as much on fiber as I should have, but I learned a lot from that. I hope you did too. So I'm going to tie a little more into the wireless piece of it. And, just some information I gathered online at broadbandnow.com. There are currently, and I don't know how accurate these numbers are, I have a feeling that they're actually low to what's really out there. But according to them, there's over 1,200 fiber ISPs in the country today. And there's over almost, roughly 1,500, which I feel like that's low also, WISPs today. So those are people that are deploying wireless as an internet service provider, or providing fiber as an internet service provider. The funny thing is as I ran down the list, there was a large number of ISPs on both those lists that I know are doing both. Or when you clicked on them and got more details about their the way they deploy and everything else, they do both. They are hybrid ISPs. So being a hybrid ISP is not a new thing. It is something that people have been doing for a long time. WISPs have been toying with fiber for a long time, and fiber providers have been looking at wireless for a while. I think it's been more the WISP to fiber than vice versa. We see a lot of, once you're in cable, you're in hardline. And the wireless guys, being pioneers of trying to bring broadband to places where you couldn't get broadband before, they've definitely studied different technologies and different ways to bring a dollar, and they've done a good job with that. So I'm going to tie more into the wireless pieces. So how is wireless similar to fiber? And Caleb touched on this a little bit with the parts and pieces. In wireless, everything is pretty much so a point-to-point, point-to-multipoint, or in-building Wi-Fi. Just like the OLTs, you have those are pretty much so like your point-to-point or like your access points that you find in point-to-multipoint. But point-to-point is basically when we're connecting two locations and two locations only to each other with a wireless connection. Now, this can be done with licensed or unlicensed frequencies. It can be done at very slow speeds or very fast speeds, depending on distances, depending on frequencies. There's a lot of variables that go into what can be done. But with wireless today, we're seeing products release at multiple gigs, even as much as 10 gigs as a wireless bridge. So point-to-point wireless is a very fast speed. Usually, it's very low latency way of getting point A and B connected. And we're going to get into more how that'll help in a few minutes. Now, multi-point is pretty much so, as it says, point to multi-point. So we're taking a single point. I like to call it a vertical real estate, whether it be a tower, a large building, a water tower, a building on top of a mountain. These are all, high points, and it will connect multiple points at a far distance. That could be close range or far range. We can do connections, 5, 7, 10 miles. Everything today is getting a lot closer, where we're trying to keep things within, 1, 2, 3, 5 miles, more of like a micro cell deployment than longer distances. But you'll have your access point talking to CPEs, which is your customer premise equipment, and that's how we make connections with radio waves versus with glass and light. So what does Ubiquiti offer on the wireless side? They have multiple product lines, and these product lines, basically have different functions so you don't go digging through trying to find everything. But you have AirFiber, which AirFiber is Ubiquiti's kind of flagship for point-to-point products. They do this in both unlicensed and licensed frequencies, and they carry very high throughput with these. You can do gigabit speeds with their licensed and unlicensed products. They primarily focus in the 5 gig, 24 gig, and 11 gig are their primary point-to-point product frequencies. The Edge Max, which is their routing series, so they have security gateways, they have routers, they do have switches, they have managed switches. All of this is part of the Edge Max line. And then they have the Air Max, which would be their point-to-multi-point product line. This is going to be your rockets, your power beams, your nano beams, prisms. These are all parts that are inside the Air Max family that allow you to connect multiple points together to a single tower or single point of presence. And then the UFiber line, which is the line that Caleb also had just talked about when it comes to the UFiber. The only thing that's not listed in here would be the UniFi line, which is their home Wi-Fi, their enterprise Wi-Fi, and that also comes into their video surveillance parts also. So they cover the wide range of everything you need for a point-to-point, point-to-multi-point, routing, switching, enterprise, and Wi-Fi all tied into one product line, which is very valuable. You learn one thing and you kind of go from there. So what are the benefits of a hybrid fiber and wireless? The biggest thing that we see today, and I go into a lot of meetings where people are like, well, we're building this ring with fiber and we've got this plan built and it's going to take us 5 years and $1 million+ or whatever the number is. And I sit there and look and I'm going 5 years. And then coming from a wireless world, because we've been doing wireless for almost 20 years, you're going, that's a long build time. I look at that and I say, well, if we have vertical assets or points of presence, we could go in with wireless and we could do that same thing in 6 months. And we could probably do it in most cases at a fraction of the cost. Now, is wireless an actual replacement for the fiber? I'm not going to say that it is, but I do believe that it is something that can get you running. It can get you to where you want to be at a faster, in a faster period of time. And it can also do it at a fraction of the cost. So what you're doing is you're getting your network to where you need it to be now, and then putting in the redundancy with the fiber as you go. That's kind of how I see as a best of both worlds action when it comes to rapid deployment. Getting past obstacles is the biggest one of all. We see a lot of scenarios where people have a fiber build. They have a project that they're trying to put together, and there's a railroad, or the Mississippi River just stepped in my way like it magically appeared. With wireless, it makes it very simple to jump, a very short distance from A to B. Being able to do like a millimeter wave product or even like a 24 gig product and have it go, a quarter mile or, a short hop and be able to do a gigabit or multi-gig and put it up in a week or two is really where the wireless piece is basically helping. It is a benefit for doing both networks, right? So they're both relying on each other. Hub and spoke, we've seen this kind of go both ways. We've seen this go, and I'm going to show you some slides in a few seconds with examples of this, but hub and spoke is probably, is another one of the big ones where you have a fiber network and you're going into a high-rise building, how easy it is to spoke out of that with wireless. Or if you're looking to become more of a fiber deployment where you can use your wireless today that's taking high-speed data to your towers and then actually do a fiber to the home from there. You're letting the wireless get you closer to the clientele and then running less fiber. And that is all going to be dependent. You have to basically look at your layout. You have to look at your terrain, look at your obstacles, figure out your cost per mile, and you have to do the math and figure out what's going to be the best course of action for you. And that's also going to be dependent on, are you a fiber provider today looking to get into wireless, or are you a wireless provider today looking to get into fiber? So that's kind of another thing. And then redundancy, which we touched on a little bit. We do a lot with city, county governments where they're doing everything in aerial fiber, And everybody's like, it's fiber, it's bulletproof, it's awesome. No, it's not. All you need is one person drunk driver on a Friday night hit a pole and your fiber's gone. Or some new construction company didn't call 811 and they start digging and they dig your fiber out of the ground. So it's not bulletproof. And they can complement each other left and right. You know, the wireless is not bulletproof either. Like Caleb had mentioned, we talk about interference and things like that within the wireless world. It's no different than, you know, a squirrel chewing through your line or a drunk driver hitting a pole. So neither one of them are perfect. So this is just a picture real quick of a fixed wireless layout. Like this might be a service provider today that, you know, has got the wireless up and running. You can see where they have their NOC and they're feeding point to point, point to point, point to multi-point to all their end users, which are residential clients, could be multi-dwelling units, could be, you know, enterprise clients. But all of these, you know, all these can be connected together with wireless, and it's all, you know, wireless from head to toe, right? And we've got the frequencies with 5 gig, 11, 900, 24, 365. All these frequencies are readily available, and, you know, Ubiquiti offers products in all these frequencies. So now let's go to the next slide. So we have fiber feeding, you know, points of presence that are closer to your clientele, and then using wireless to be that multi-point connection back to, you know, to the houses, to the businesses and everything else. And like I said, we can do this fast. You know, we can do this in weeks instead of months. And that's one of the main pieces here that we see in a hybrid network. If we go to the next one, we have wireless feeding fiber, okay? And so here's an example of, I was dealing with a client that they already have licensed microwave backhauls going to every one of their towers. And they want to hit more houses residential, and they're going to more of a fiber play. And they're like, well, we're going to put fiber in everywhere. But then when we sat down and designed it, it was actually smarter for them to use their point of presences that they currently already have with, you know, gigabit licensed backhauls everywhere, and then use that to feed their fiber to the home, bringing the fiber runs a lot lower, you know, lower distances, a lot closer to the clients, and doing it that way. Another thing that we've seen a couple clients, and this is one that I really like. You know, we talk about microcells and everything else. So they've been a fiber provider for a long time, and they've been going into areas where it's been very tough to run fiber to the home to every single home. So what they did was they toyed with some ideas. Now they go into a neighborhood and they might have like 4 homes that they strategically pick, and those homes will be fed with fiber. And then what they do is they cut deals with the homeowner and everything else, and they put some wireless on their roof. And now that feeds a couple other distribution points in the neighborhood, and all those distribution points feed every other house in the neighborhood. So they're using fiber to the home to only 4 or 5 places, and then using a microcell setup to be able to connect each one of the houses with wireless. And they're doing it at a lot lower cost than what they were doing fiber to the home, and they're still able to provide those, you know, 50 meg packages, 100 meg packages, and they're being able to do that because they're bringing the wireless closer to the end user. So in this case here, though, you can see where they're using, you know, wireless to get to their point of presence or to their tower sites, and then beyond that, they are, you know, beyond that they're using the fiber to the home. And you can also see in here the redundancy piece. Once again, if you're building a large network that's going to take time, why not get wireless in place and start, you know, gathering revenue on that ahead of time rather than waiting, you know, a year to plan out or anything else when the wireless can go in right away. The other thing that can be done, and we've seen a lot of this, especially with Ubiquiti's price points, is people will put up wireless in an area to get their name there, to test the demographic, to test how many takers they're going to get on their internet packages. And they'll put that in place, and they'll start gaining market space, and they'll start gaining name recognition, and they'll start bringing revenue into an area before they've even laid a fiber line. So it's a great way to test bed. And you can also see, we talked about the redundancy piece here of having fiber and wireless together, especially in a backhaul environment. You know, that's a great way to know that, okay, with wireless, we're dealing with interference. With fiber, we could be dealing with a drunk driver or somebody cutting our line, but then together we can do this, you know, piece and piece together. so that's kind of like how we're seeing that these guys, we're seeing these guys play together. So what I have here is a couple questions right now that I'm going to get into. So you were talking about so we have one question here that says, which radios are actual gigabit throughput? The ones that so gigabit throughput right now, it depends on if you're talking about, so the AirFiber line offers gigabit radios, and those are going to be especially in the 24 gig and also in the 11 gig. Those are going to carry gigabit speeds. Now, as to talk about if that's going to be a full duplex or a half duplex speed, that's going to be all dependent on your deployment, your distance, and that's going to be kind of, when you get into millimeter wave, which millimeter wave is a product that currently is not being offered by Ubiquiti. That's your 60 and 80 gigahertz products. Those products there will carry multiple gigs at short distances. Let's see here. What else do we have for questions here? So what is the maximum distance for a wireless hop under ideal conditions? That's actually going to be kind of a trick question there. And the reason why is because different areas carry different obstacles for wireless. Like for instance, depends on your frequency, depends on if I'm deploying this in Florida or if I'm deploying this in the Arizona desert. Those are variables when it comes to the wireless piece. Primarily when we're designing a wireless service provider, today we're seeing a lot of towers being within 5 to 7 miles from each other, or 3 to 5 miles, where that way you get a good overlap on your frequencies and you get a good overlap on your RF, and that helps with increasing your connectivity. Your frequency is another thing that kind of plays a big role in that. 5 gig versus 365 versus 900 megahertz, those all carry different characteristics in wireless. So that's something that you could, if you have an idea of what you're trying to accomplish, it'd be good to discuss it with a rep, and they would better be able to kind of drive you in the right direction for what products are going to work for the distances and speeds you're looking to supply. Caleb, are you still with us?
Yeah, I'm here.
There was a couple of questions in there on I wanted to see if you wanted to take those.
Yeah. So first one, let's see here. Will the management system work if you only use the G-PON equipment but other vendors' goods upstream? Yeah, that's not a problem at all. So that was the point of me saying, hey, this is the base, G-PON topology. So you can insert that wherever you want to put it into. So, if you have the UFiber G-PON, LLTs and the ONUs, those need to be the same to communicate with each other. But whether you plug that into a Ubiquiti switching router or Cisco or Juniper or whatever else, doesn't matter. You're all good there. So the management of the device will come from your, either direct, you can log directly into the OLT and do it, or if you're doing it with UNMS, as long as it's on your network somewhere where you can talk to that box, you can drive all that. So that's no problem whatsoever. Next, when will more capacity be available at the OLT? So instead of 2412, when will it be 10 by 5 or so? No immediate word on any sort of plans as to when 10 gig GPON is going to come from Ubiquiti, if it does, when. Now, they're real hush-hush about dev stuff, and as I've gotten older and crankier, I've become a lot more of a pragmatic type of guy, try not to leave on the bleeding edge too much. So, a lot of times I don't get super excited into the dev stuff until, products are ready to roll and everything else. But it could be pretty soon, it could be down the road. Ubiquiti is really good at staying on top of current trends and where the tech is going. So I would expect that, could be something in the future, but like I said, no firm plans one way or the other. Let's see here. Does the ONU have UPC or APC ports? No, it does not have a UPS option or battery backup option directly. Now, it is powered off the Ubiquiti 24-volt PoE, and there's a ton of options out there to put it on a DC plant or to put a battery backup. It will require a little bit of engineering, but it's a relatively simple type of setup, and you can get it figured out pretty easily. But natively, no, not a native port. see. Loss, millimeter wave. Yeah, millimeter wave question. There's no products in the immediate pipeline for millimeter wave from Ubiquiti, but I can assure you that they are fully aware, and I would expect we would see something in the near term. Millimeter wave has gotten really popular lately as wireless node size has decreased, as we've got more and more capacity requirements and stuff like that. You know, there's a lot of development in millimeter wave space, and I fully expect that if and when they do develop a product, it will certainly be disruptive in the market for sure. All right, hold on, let's see. Noted, does G-PON math like that or average problem using share the amount? All right, so we got a question here. It's kind of long, but basically it's all about splitting the bandwidth on the G-PON system. So as long as the capacity is there on your number of splits, then you'll be able to run up to that higher capacity. So, you know, if you got a 2 gig port and you split it a 1 to 2, then it's going to split, you know, you're going to get half and half split. Whether or not you use that full gig and a quarter down and, you know, 750 up, you know, whatever that split is, you know, the split between splits the airtime and the TDMA stuff, but it's not dynamically, you can't push it, you know, a whole gig one way and then try to parse off the others. But there are a lot of options. But let's see, your speed splits and stuff are fairly standard based when you look at GPON deployments. And there's a lot of sort of literature out there, and we'll see if we can dig something up on that. Hang around gigabit speed to end user route. So the gig speed to an end user with a UFiber implementation, like I said, you're going to have to keep your splits pretty low, you know, 1 to 2s or direct splits. Although honestly, if you're looking to run a full gig to every single user, you know, GPON might not necessarily be the best fit. Using a GPON network deployment, you were trying, you know, you're not necessarily running gigabit. If you want to run gigabit, you're probably running active, so you can give them each a dedicated port, especially if you want any sort of SLA on it, so on and so forth. GPON is about not necessarily dumping out tons of gig ports to the users, but it's about getting a very high number of high capacity subs, whether you want 100 meg subs or 50 meg subs or whatever that may be. You know, that the ability to build that out in a low cost sort of way, because you're not having to maintain all this active plant at every single node junction or split. This is sort of the big benefit of what GPON is. And it's a trade-off. And this is why I'm not going to say GPON is better than active. You know, there's a tools in the toolbox approach, and we've got to look at it from, you know, what are my design goals? What are my end user goals in terms of speed, capacity, and packages? And am I going to get the ARPU that makes sense that I can pay for all this active plant? So if I'm selling gig links and I'm charging enough and making enough ARPU off of that and revenue that I can justify this active plant, have at it, man. Go nuts. There's a lot of really cool options available on high capacity active networks and outdoor deployments. If you're a lot more cost conscious or budget driven, or you've got a customer base that's not going to want to pay for a gig link in every one, then you've got the ability to roll back, scale things down a little bit, but deploy in a much more cost effective manner. So anyone else? I think that covers, let's see. All right, we've got a few more. So, the fiber type. The fiber type question, if you'll send your questions to marketing@DoubleRadius.com, we'll get you squared away. A few other questions. Network design service. We're not doing a lot of active design stuff now. We've just recently started to play with some of the stuff. You know, we can give you some generals. We can help you out with some things for sure. That's not a problem. But in terms of full network design, I don't think we're at the point where we could do it effectively and efficiently. But in the near future, I would expect to be offering more of those types of services to those that are interested as we get more, you know, into the dirt with our deployment stuff here. ONT compatibility, there's if you look on the I'm pulling a blank here. If you go in the help articles, the getting started, somewhere in that thing, they give you a list of OLT compatibility. So the ONUs are not going to be compatible with third-party LLTs, but the OLTs are compatible with some third-party ONUs. You pick the profile that you want to use in your deployment type, and they mentioned a handful of them there. Some more of the more generic profiles that you run, you may be able to push some different ones, but it was mentioned on the site. Yes, each port on the OLT provide 2.4 by 1.2. Yes, it does. Splitters, all those other sort of accessories that I mentioned, I don't have a firm yes or no, go no. We've got experience with some, but not that we want to vouch. We are looking to increase our product offerings as the G-PON stuff really starts taking off. But you know, if you go somewhere like Fiber Store, you know, you're going to find a wide variety of options there. A lot of other sources to find some of these things. Let's talk a little bit about management, you know, having various different controllers and stuff, because this gets brought up a lot with UNMS implementation and various other things. You know, they've had multiple swings at implementing a global network management system. Been some stops and stutters and pluses. And what it all boils down to is all the core family lines, your UniFi, your EdgeMax, your AirMax, your AirFiber. These have all spun up from different software cores, different application cores, different teams. So, you know, it's all really good stuff, but it's all built with extremely different cores. So to get all of them to talk to the same management type of language and platform has taken quite a bit of time for that to develop. So and we run into that a lot. You know, we don't want multiple management systems. At some point, you know, in the hopefully not too far future, we will have a fully, truly unified solution, Waka Waka, that will include the UniFi stuff along with all the UNMS. But at the same time, you also taking the split versus your, you know, your sort of enterprise network versus operators, so on and so forth. But it all basically comes down to resource and then being able to get the platforms all up to the same common core. So at that point, we can build and improve the system and be able to keep everything lockstep together as time progresses. So, and on that note, I think, Chad, that's it.
All right, thank you everybody for joining us today for the webinar. And if there were any other questions that were not covered online, we'll make sure to get back with you offline. And if you could just take a moment to fill out the survey that will appear on your screen. With that, we hope you have a great afternoon. Thank you.